All right, hey, honors chemistry. So on our third snow day, we were gonna actually do some notes in class on percent composition. So I'm gonna get us continued to go. So yesterday you did a percent composition by mass given the masses of elements, and then you had to figure out the mass of the compound. Today we're going to talk about how I could get percent composition without being given masses. So if I look at my examples here, I have two compounds, K2CrO4 and K2Cr2O7. And here are all the percentages of the elements in the compound. Just by looking, I could see it says which compound contains a larger percentage of potassium. Just by looking at the formulas, I really can't tell, but I have some percentage data here that tells me that obviously K2CrO4 has a larger percentage. We're going to talk about how I could get these percentages. So, definitions wise, we mentioned it and you were doing it, but this is known as percent composition. It's the relative amounts of elements in a compound. The percent composition of a compound consists of a percent by mass. So what I do is I have the mass of something, whether it be X, over the total mass times 100. So we're going to do an example. So let's see if we could try and get the percentages of K2CrO4 given in this circle chart here, or pie chart. So if I'm given the chemical formula, we can determine the percentages of each element in the compound using the molar mass of each element and the molar mass of the compound. And what you will see is molar mass times however much of that element is over molar mass of the compound. That whole thing times 100 will be giving me my percentage. So you'll see this later. So we're going to work based off of this little schematic over here. So let's look at K2CrO4. If I want the molar mass of K, if I look easily on the periodic table, if you remember, those masses on the periodic table are what we call the molar mass. It's the mass of 1 mole of that element. If I want the molar mass, I just look at the mass on the periodic table. It's the number that's on the bottom. And if I want the molar mass of the compound, I add up all the masses of the elements in the compound. So the molar mass of K, according to the periodic table, is 39.098 grams per mole. The molar mass of chromium, Cr, is equal to 51.996 grams per mole. And the molar mass of oxygen is 15.999 grams per mole. Now, in this compound, there are two potassiums. So I'm going to figure out the mass in the compound, the mass of K in the compound. There are two potassiums. So if I take this 39.098 and multiply by 2, I'm going to do 2 times 39.098 grams per mole. I will get my mass of potassium in this compound. So I'm going to record that mass on the bottom here, and this is going to be very important. I'm doing this piece by piece, but you'll see why later. So 2 times 39.098 is equal to 78.196. So I'm going to say 78.196 grams of K. Okay, this is how much potassium is in this compound, technically, if I have a mole of the compound. For chromium, there's only one of them, so the mass of chromium in the compound is 51.996 grams of chromium. And then for oxygen, if I want the mass of oxygen, there's 4 of them. So I'm going to do 4 times 15.999 grams per mole. And some of you may ask, can I just do times 16? Absolutely. Just be careful for significant figures, or if the answer is like off, like my answer is a little bit off than your answer in decimals. All right, so 4 times 15.999, 63.996. So 63.996 grams of O. Okay, now if I want the molar mass of this compound, I just add these three together. 78.196 grams of K and 51.996 grams of Cr and 63.996 grams of O. If I add them all together, I'll get a molar mass of 194.188 grams per mole for K2CrO4. Okay, so there's a reason why I did this. I have the mass of potassium, the mass of chromium, and the mass of oxygen in this compound. If I want the percentage, I just take the mass of K and I divide it by the mass or the molar mass of the compound, and I times it by 100. Okay, so the mass of K in the compound are the two Ks, right? There's two Ks in this compound. So 1K, 1 mole of K is 39.098. There are 2 moles of K in this 1 mole of compound, so I multiplied by 2. This is my mass of K. So all I'm going to do is 78.196 grams of K over 194.188 grams of K2CrO4. And I'm going to multiply that by 100. All right, so I'll do 78.196 divided by 194.188 times 1. And this is going to give me my percentage of 40.26 or 40.27%. So 40.27% of K. And if we look all the way at the top, 40.3% is how much K is in this compound. So that's where that number came from. Let's continue that and do the other one. If I want the percentage of chromium, I'll just do the mass of chromium over the mass, the molar mass of K2CrO4. So I'll do 51.996 grams of chromium over 194.188 grams of K2CrO4 times 100. Sorry if it's getting a little messy. I'll do 51.996, which is the mass of chromium in this compound. There's only 1 chromium, 1 mole of chromium, so that's the molar mass, divided by 194.188 times 100 to give me my percentage, and I get 26.77 or 26.8. I'll do 26.77% chromium, and if I look all the way at the top, it was 26.8% chromium. Oxygen